Hey guys. Can you hi Noel. Can you post in your class WhatsApp chat that we're on? Maybe somebody forgot. I would appreciate it. Okay, let's get attendance going here. We're in session. So let's see. We got Noel's here and Avi's here. Okay, Savoy's here. Josh is here. Oh, Milo's here, sorry. Okay, Liz is here. Giannis is not here. This is oh, okay. Thanks, Giannis. I'm going to post it, Giannis, so then you can see the AP Physics online. I'm not quite ready yet. I have to convert the session, but it will be posted so you can see it there. Okay, Finn's here. Okay, good. Relatively low attendance. I have right now. It looks to me as if Neela is not here. Tis is here. Good. And we don't have Neela. We don't have Haley. We don't have Colin. We don't have Keanu. We don't have Charlotte. Jan. Zidane. Willy. Is that correct? Any of those people I just read off, are they here by any chance? Oh no, Neela. Mila is here. Neela is not here. Yes, Mila is here. M is here. N is not here. But can't figure out how to comment. Okay, thank you. I'll check her as off as being here. Thank you. Haley is here. She can't comment. That's good. Anybody else? Okay, thank you. So I hope you're all well. And I hope you guys have maybe been working on our online lab. Hi, Neela. I hope you're enjoying it. I think it's pretty cool. I've got some nice comments from people about the iceberg and putting styrofoam in the water and seeing how the level goes up and down. And what I wanted to do today with you guys is I wanted to kind of try this lab live. You could try this at home as well. This will be an optional activity for you, but I kind of try to figure out how we could do this lab for real as well at home, and we'll see how it goes and see if that works. Okay, I actually have never tried this, but here we go. So the equipment I have is I've got a kitchen scale, okay? Just a regular kitchen scale that you might be using for baking, okay? And I have a glass of water. There we go. I have a marker. There we go. Make sure this is erasable. If you mark we're going to mark the glass. So I want to make sure that we're going to be able to erase that, wipe that off. So this is a whiteboard marker. That should definitely work. But if you're going to do this at home, you could try it, but please don't mess up your glasses. Obviously, your parents might be unhappy. I'm going to have another cup that I use to actually, I want to pour some water out of the other cup. So I have that. And then I have an object that might look familiar to you guys. I have a block. This is block A. I've got an aluminum block, but you guys could do the same lab at home, and you could use a rock or something else that's a little bit different from last time, because we want to use the method that they described in our Yeah, it's not an eraser. It's actually an aluminum block. The aluminum block we used in class, I took that with me from school. Hi, Jan. Jan is here. Good, I'll mark him present. And we'll want to get the mass of the, we'll get the volume of this. So here's the question I got for you. Density of aluminum block. Home lab. Okay, so the first question I have for you guys is, if I want to find the density of this thing, okay, what do I have to measure about the block? Okay, mass is so we need to find two things. We need to find the mass and we need to find the volume. So I've got this is. I hope this works. I'm going to kind of turn you a little bit here, so you can look at the scale. That work? Maybe I can elevate this a little bit. That might be easier to look at. I haven't tried this out yet. Oh, I can't elevate it because it has to be flat. Sorry. Let's see. So you can kind of read it, right? Okay. So on this scale, there's a couple of buttons. There's a tare button here, and there is a mode button over there. Okay. So I'm going to switch the mode until it gets to, it needs to stay over here. I'll hold that up for this. It needs to say grams, and it doesn't say that. It says milliliters. It says fluid ounces. It says, again, milliliters. I hit again, fluid ounces. Now it's on grams, so that's good. And I will let this sit here. And the other thing that's important about a kitchen scale like this is it is designed to allow you to measure the additional mass that you would have if you had a bowl and then you pour some flour in there, okay? So you put the bowl on here and then you hit the tare button here, or Tara auf Deutsch, and then it zeroes out the scale with the bowl on it, so then you just measure the mass of the flour. So we have to make sure to actually measure zero when it's supposed to measure zero. So we hit that button and it settles on zero. Good. And then we're going to put the block on here and it's going to measure its mass. And I get 161 grams. And I'm just going to write that down here so I don't forget. 161 grams. So we got a mass of 161 grams. Whoa, something popped open. Oh, okay. I see what happened. You can see that? Yes, you can. Okay, so we've got the mass right there, but now we want to find the volume. Okay, so on the actual lab, the lab on PhET, you guys were asked to, you had to also find the volume on the No, you don't, Ari, you don't have to do the lab experiment. If you want to, you can. So it's really the same. I just wanted to show you how it's in real if you were to do it. So we found a mass of 161 grams. Great. And now the question is for the volume. And on the PhET lab that you guys were working on, you put the block into water, and then you were able to find how much water was displaced. Okay? Does that sound familiar? And just a yes would be awesome. Colin is here. Okay, good. Colin. Anybody else show up? No. Okay, yeah, Jan, I got you. Okay, cool, thank you. So let's take a look here. We've got the water container here. It's hard to see it this way. Let me see. I can probably get a little stack of books over here, improvise a little bit. There we go. All right, so I got a couple Gesellschaftsspiele over here that are propping up our water container now. And we can see that this is right now the level of water before we place the block in there. Okay? And now we're going to see what happens when we place the block in there. It should go up a little bit. And where'd the block go? Is it on the other side? Whoa. Here it is. Found it. Okay, so that's the level we were at. And now we're going to put the block in there. Try not to break your glass is another good tip. So there we go. And now our water is at this level. Agreed? See? So it's gone up a certain level. And we can figure out how much water that is by, again, using our household scale. Okay? So our household scale, I'll put that on here, right, has a function where we can actually measure volume. Remember earlier when we clicked through these and there were different things? If we hit mode again, it says here fluid ounces. It says milliliters of milk. We're not using milk. We're using water. There's actually a function where you can measure the volume of water that we have. Okay? So we're going to click it to that. We're going to put this container on there, which is going to be the container we pour the water into. Place that on there. Okay? And I'm now going to, can you kind of see it? A little hard to see. Let me see if I can get closer. There we go. Let's come give you a better angle. There we go. So we're going to now zero this thing by hitting Tara. Boop. And it should go to 0. It did go to 0. Good. And what we're going to do now is we're going to pour water out of this thing over into this container until we're at that level. Okay? To get the water that was displaced by our aluminum block into the cup. Let's try that out. Let's see where we are now. That's pretty close, but not quite. So I'm going to pour a little bit more. Just be careful. There we go. Let's see where we are now. And you can see we're now at the level we were at previously. So now when we put this thing on there, we should have a measurement of the volume. In this case, it's 55 milliliters. You see that? Okay. Or 55 cubic centimeters. And I'll write that down over here so I don't forget. And again, you can do that at home as long as you use a non-permanent marker. Your parents are going to be upset if they find scientific data. Well, maybe not. If they find scientific information data on their scale they use for baking. Okay, so let's come over here. I'm going to back on the main screen there. Okay. So we have our cooking scale here. Oh, if your scale only measures grams, a gram of water is just about a milliliter of water. So you can just use that. Okay? So a gram of water and a milliliter of water is the same thing. Good? Good question. So we've got our data. Let's take a look. We've got 55 milliliters and 161 grams. So we have two pieces of information now. There we go. Okay, and that's the same thing as 55 cubic centimeters. Just a reminder that a milliliter and a cubic centimeter, that's the same thing. And now that we have those two pieces of information, we've got the mass is 161 grams, and we have a volume of 55 cubic centimeters. How can we put those together to get the density? What's the equation for density? Just type it in the chat if you know it. Anybody know the equation for density? You guys there? Mass divided by volume. That's right. So mass divided by volume, okay, is the equation. And sometimes we abbreviate that. We have a weird symbol for density. Good, good, nice, good job. So density is like kind of like it's a little row, like row, row, row your boat gently down the stream. Okay, that's a different thing. Okay, so this is the row, little Greek r. M is mass and V is volume, and we can plug the values in. And we plug in 161. And we plug in 55 cubic centimeters. Good. That's showing up. Sure is. Good. That is rho. Yep, that's good. Now use your calculator to find 161 divided by 55. If you don't have a calculator, you probably have a phone. I do. So I'll just use my phone for this. And let's see what we got there. 161 divided by 55. 2.9 is what I get. Rope. Oh, yeah. It's row your boat, not rope your boat. But yeah, cool. 2.9. That's cool. Yeah, I got that too. Here's my value. I can hold it up here. You can see it. So I got 2.92 or just about 2.9. And you just saw the message I'm supposed to call my mom. Call your mom. Well, you guys are living with your mom probably, but you know what I mean. 2.9 grams per cubic centimeter. Good. So that's the answer I found. Do you guys remember the density for aluminum that we looked up as part of our lab for the density that you're supposed to have? That's the accepted value for the density of aluminum. Do you guys remember? If you do, just type it in the chat. Good job. 2.7, that's correct. So this is our value. So our experimental value is that. And we'll write it over here that the accepted value is 2.7 grams per cubic centimeter. On the screen? Kind of. There we go. So this is the accepted value. And here's our value that we just got. And of course, the lab we just did was, boy, it doesn't get much more simplistic than, we got a kitchen scale, we got a glass of water that is, realistically not the best, most precise measurement of that volume. Still, I think we got an answer that's quite good because we're within 10%. The difference is only 0.2 difference. And you divide that by this value to see, oh, it's less than 10%. It's about 7-8% difference. So our answer is actually quite good, even though our lab is, not super scientific. Well, it is scientific. It's not like high-tech equipment or anything like that. And if you want to, you can try this at home and measure the density of a rock you get from your garden or something else. Make sure you don't break anything. Woot, woot. Yeah, I thought that was cool too. I'm pretty excited that it worked out. I have one more thing to talk about in terms of our schedule for our class. We have an unfortunate situation. I think it's unfortunate that there are quite a few Fridays that are officially not school. So the next 2 weeks, May 1st and May 8th are official school holidays. Now, if we were in school, we'd have one period of class a week canceled, but we would still meet for the other period. So I think it'd be a shame if we lost our class at both of the next weeks. I think that's a lot of time to lose. So I'd like to meet another time. So our other time that we have class is period. And I think that's pretty brutal that if we wanted to meet, we'd have to meet at 8 or 8:15 on Tuesday. I think that is very, very early. So maybe that's a little bit too early. So I'm thinking maybe we'll shift our live stream to, I agree. 2 a.m. I like that idea. I was thinking maybe shifting to lunchtime another day. Okay, so either, and I'm looking because I have several classes that I normally meet with on Friday. I couldn't do, I don't think I can do Thursday or Monday, but I could maybe do Wednesday or, whoopsie, where do we go? There. Here we go. Here you go. Sorry, I just switched for some reason. Okay, so I was thinking maybe on Wednesday or Tuesday, but I'll let you know for a different time. But I want to at least do one live stream. So maybe we'll move it. That's a good idea. Man, sometimes I have good ideas. Not always, but sometimes. So I think I'll do Tuesday, not the coming Tuesday, but next Friday we won't have class, but then the following Tuesday, and that kind of replaces. Right. So we'll do Tuesday lunch to replace the class. So our next class is May 5th, Tuesday, May 5th at lunchtime. Okay. So Tuesday, May 5th at lunch, and I will send you a message on Google Classroom as well, and I'll make an assignment. It'll be at 12:20, the regular school, 12:30. 12:30 during our time that we would have lunch at school, 12:30 Tuesday, May 5th, 12:30. I'll write it here. So I'll write it in as a comment here. Boop. Next live stream. Whoa, why is it not working? Oh, it did work. Okay. Live stream Tuesday, May 5, 12:30 to 1300. Is that gonna, if I hit enter, does that work? It should work. Yeah, it did work, I think. There we go. There we go. Next live stream, Tuesday, May 5th, 12:30 to 1300. So not the coming week, no class next week. We will have the online assignment that you're already working on, but then we'll see each other again on Tuesday, May 5th. Okay? So nice hanging out with you guys. Have a nice weekend. Don't forget to put the chairs up. Okay, bye.